Welcome back to another session of past exam papers. Today we're dealing with Analytical Geometry grade 10. So let's get into it. We are given a quadrilateral here, and what should we do? Let's see the questions. They say determine coordinates of A and B, which happen to be midpoints of PQ and PS respectively. So we have got point A and point B. We are told that this point A is the midpoint of this line PQ and this point B is the midpoint of line PS. So we must find the coordinates. Alright, so we're going to start with the coordinate for the midpoint of line PQ, right? So we say PQ is equal to, when you're calculating for the midpoint, you say this coordinate plus that coordinate, the x coordinate, which is -5. So we say -5 plus, here we've got -4, open bracket -4, divided by 2, then same colon, we go to the y coordinates, we've got 3 and we've got -1. So it's 3 plus, open bracket, -1 divided by 2. Now what do I know? I know that my positive and my negative gives me a negative. So in other words, here I've got a negative. Now I say -5 and -4, which gives me -9. So I've got -9/2. This is the final x coordinate for the midpoint of PQ. Then here if I come, I've got positive and a negative, which is a negative, and 3 minus 1 is equal to 2. So I've got 2/2 here. Then from there, this one should be reduced to the lowest term. So now I say -9/2, and 2 divided by 2 is equals to 1. Now this is the midpoint of line PQ. So we say therefore the midpoint of PQ is equal to these coordinates. But remember, we were told that we should use coordinate A. So therefore A is x -9/2 and y is 1. Alright, done. Now we must define the coordinates of point B. We are using what? Point P and point S. So I'm going to write this answer on the side because I have got a feeling that they're going to need it later on. They're going to need those coordinates. So 1. Alright, what am I going to do now? I'm going to erase this so that I can have some space to work with. Alright, then we calculate for the midpoint of line PS afterwards. Alright, so let's calculate. Midpoint PS is equal to, my x on point P is -5, plus my x here on point S is 2/2, and then the y is 3 plus 1. 3 plus 1 all over 2. Now, what do I say? -5 and +2, it gives me a -3. So I've got a -3/2 here, and 3 plus 1 is equal to 4. So I've got a 4/2. This should be reduced to the lowest term, so which is equal to -3/2, and 4 divided by 2 is equal to 2. These are the final coordinates. We say midpoint PS, right? Then we say therefore, remember the midpoint of line PS was called coordinate B, point B. So the coordinates at point B are -3/2 and the y value is equals to 2. I take my answer, I place it here. Let's see if later on they are going to need these coordinates. Alright, no problem. So we are done. Now we go to the next question. What is the follow-up question? Hence showed that QS is equals to 2AB. Now, where do we find QS? QS is this point here. We've got Q, there we've got S, and this is where A and B are. So now they're asking us to prove that this line AB, which you can see that it's clearly longer than line, this line QS rather, is clearly longer than this line AB, right? and we are told that this QS is 2 times longer than AB. So for AB to be equal to QS, we have to multiply by 2. It's all in the equation. So we're going to use our distance formula. We need to calculate the distance of line QS and the distance of line AB. Then we can prove whether the equation is correct. So the word hence means that use here. They said hence showed that. The word hence means use the answers from the previous question. So those coordinates which I said, let's put them aside now. They're going to be useful in terms of calculating the distance of what? Line AB. So let's start with QS. So now I say QS is equal to open bracket. Now I must say x2 minus x1. So my x2 is 2 and here I've got -4. So I put a square bracket here and I say 2 minus open bracket, this -4, I place it inside the curly brackets and then I close my square bracket. Then I say plus, I open the bracket. Now I check y2 minus y1. Also I'm supposed to use square brackets. So I put square brackets here. Then I say 1 minus open bracket -1 inside the curly brackets. Then I say square. Then now I put the hood of the square root, which is now equal to. Now here I know that negative times negative, it's a positive. So now I say square root open bracket 2 plus 4 close bracket squared, right? All right. Plus here negative and negative is a positive, and we now have 1 plus 1, which is squared. And 2 plus 4 here is equals to 6, and 6 squared gives us 36. So we've got 36 here, square root of, plus 1 plus 1 is equal to 2, 2 squared is equal to 4. We've got 4 there. So 36 plus 4 is equals to 40. Now we must find the answer to the square root of 40. So if I go to the calculator and I say square root of 40, square root of 40 is equal to what? 2 square root of 10. So the final answer is 2 square root of 10. 2 square root of 10. That is the distance of line QS. Now let's find the distance of AB, and we're going to use these coordinates. So we now say the distance of AB is equal to, open the square root, then we now say x2 minus x1, which is 2 minus 1. Oh, I'm looking at y, sorry about that. X2, which is -3 over 2x, 1 is equals to -9 over 2. So I come here, square bracket, -3 over 2 minus open bracket -9 over 2 close bracket square bracket squared plus y2 minus y1, which is 2 minus 1. So 2 minus 1 close bracket squared, which is now equal to, this negative and negative gives me a positive. So now I've got -3 over 2 plus 9 over 2, which is squared, and I have a square root there, plus 2 minus 1 is equals to 1, 1 squared, which is equals to 1, like that. Now the fortunate part is that the denominators are identical, so I just say -3 plus 9, which is equals to 6. So I've got 6 over 2 squared plus 1. It's still under a square root. Now observe here, 6 divided by 2 gives us 3, and 3 squared gives us 9, and 9 plus 1 is equal to 10. So I've got square root of what? Square root of 10. Now I say therefore AB is equals to 10. But let's remember the answer that we got for QS here. Let's say therefore QS is equals to 2 square root of 10. Now remember, what were we given? We were given here that QS, so if I come and I write my QS is 2 root of 10. So I say 2 root of 10 is equal to, there is a 2 here which I must multiply by. So I write the 2 multiplied by, then I've got a root 10, which is the answer I got, which is the root 10 there. And 2 root 10, 2 multiplied by root 10, it gives me 2 root 10. So therefore 2 root 10 is equals to 2 root 10. I've proven this equation. And just like that, I'm done. Now we go to the next question. What is the next question? It says that show that line AB is parallel to line QS. So they're saying that I must show that this line AB, it is parallel to line QS. There. Now, here I'm dealing with what? Here I'm dealing with analytical geometry. And what do we know about parallel lines? We know that parallel lines have got equal gradients. So I should just calculate for the gradient of line AB and the gradient of line QS. If those gradients are identical, it means therefore that line AB is parallel to line QS. All right. So when I'm looking for the gradient, now what do I say? I say gradient, letter M stands for gradient, AB is equals to, now I say y2 minus y1, which is 2 minus 1, right? 2 minus 1 all over x2 minus x1, which is negative 3 over 2 minus, open bracket, negative 9 over 2, like that. Now, what do I know? I know that 2 minus 1 is equals to 1 all over. Negative times negative is a positive. So here now I've got a negative 3 over 2 plus a 9 over 2. Now, identical denominators. So I've got 2 over 9 minus 3 is equals to 6. Wait a minute. Before I make a mistake, I must write my numerator 1. So now I've got 6 over 2. But I know that 6 over 2 is equals to what? 6 divided by 2 is equals to 3. So now I conclude that therefore the gradient for line AB is equals to 1 over 3, like that. That is the gradient of line AB. Because I said 6 divided by 2, I got 3. There's the 3. Now on this other side, on this other end, I must calculate the gradient of line QS. Gradient of line QS is equal to, what do I know? I say y2 minus y1, which is 1 minus minus 1. So 1 minus, open bracket, negative 1 all over. Then the x is now 2 minus what? Minus 4. So 2 minus, open bracket, negative 4, like that. On the next stage, these two, they must multiply. So then I get a positive. So I've got 1 plus 1 all over, negative and negative, it's a positive. So we've got 2 plus 4. 1 plus 1 is equals to 2. And 2 plus 4 is equal to 6. Now, this should be reduced to the lowest term. We find a number that divides 2 and 6 without leaving a remainder. It shouldn't be 1, which is 2 over 2. 2 divided by 2 is equals to 1 over 6 divided by 2 is equals to 3. And voila. Therefore, the gradient of line QS is equals to 1 over 3. The gradient of line AB is equals to 1 over 3. Then I conclude that, therefore, it tells me that line AB is parallel to line QS. And just like that, you are done. Please, if you found this video to be helpful, please subscribe, share, like, and comment. Thank you.